Okay, so LCM 14 and 49. This is the last section, 6.3. This will take us 40 minutes probably. We got to take a break here in 10 minutes or so. Okay, 14 and 49. I want to find the LCM. What are they talking about? Well, that's like, it's the same as the LCD, or common denominator. It's the same thing. If you want, you could pretend the 14 and the 49 are like denominators, and you're trying to find the common denominator. It's the same thing. You want to find a common denominator for 14 and 49. What do 14 and 49 both go into? Now, I want you to know this is the opposite of factoring. It's exactly the opposite. In other words, if I had 14x plus 49, say, and somebody said, hey, take out the GCF, what would the GCF be? What goes into both of them? 7. Probably a lot of you know 7 goes into 14, 7 goes into 49. Yeah, that's not what I'm trying to find. LCM is the opposite. It's not a little bitty tiny number that goes into them. It's a number bigger than them that they go into. It's the opposite. So it's the opposite of GCF. So it's not GCF. LCM is bigger than them. So we're saying, what's a number bigger than these guys that they go evenly into? Well, there's a lot of ways to find them, but my favorite way is what I learned from Miss Bazarinator. Anybody have Miss Bazarinator here? About 8 or 9 years ago, she showed me her method. It's real good. I mean, she got it out of some other book. She didn't invent it, but it's good. And that is, you just put them in a box. So I'm just going to take the 49, the 49, 14, and the 49, put them in like an L box. That kind of looks like an L, you know, for LCD, LCM, same thing. Put them in a box, and then you go out here and you say, all right, you kind of do the factoring thing to help you find the LCM. So like say, what goes into 14 and 49? Well, 7 does, right? 7 goes into 14 2 times. 7 goes into 49 7 times. That good so far? And now, I would do another layer, except nothing goes into 2 and 7, other than 1. I mean, 1 goes into everything. But nothing else goes into 2 and 7. So you don't do another layer. Sometimes we do when more stuff goes in. But we don't. Okay, so great. So I'm done. Where's my answer, though? Yeah, it's all the outside stuff. This, and this. You times them together. If you do that, you're going to get 98. That's the answer. That's the LCM. 98 is the number that both 14 and 49 go evenly into. It's the lowest number they both go evenly into. It's the least common multiple. So there we go. Is that good? Questions on that? See how to make that L box thing? We'll do a lot of them. 6 and 25 is a weird one. I'm going to do it with you. 6. So on this one, they're giving me, they want the LCM of 6 and 25. 6 and 25, if you stick them in a box, nothing goes in, other than 1, right? I mean, nothing goes into 6 and 25, nothing at all. So in that case, what do? When nothing goes in, you just multiply the numbers. So 6 times 25, 6 quarters. How much money is 6 quarters? $1.50. Yeah, 6 times 25 is $1.50. That's our answer. That's the LCM. That's the number that 6 and 25 both go evenly into. Only if nothing divides in, then you just multiply them. Yeah, that's right. Yeah, sometimes I've noticed over the years, students think they can always find the common denominator that way. Just multiply them together. No, that won't always give you the least common denominator. That'll always give you a common, but not necessarily the lowest common denominator. So you can only do that when nothing else goes in. Okay, let's keep going. So they want the LCM of 4, 6, and 3. So that means you put a box, you put 4, 6, and 3. Do the L box. And basically you do 2 numbers at a time. What can I put out here that 2 numbers will go into? Let me scoot this over. Could do that, or 2. So yeah, we could do 3. 3 does not go into the 4, but it goes into 6. 3 goes into 6 2 times. 3 goes into 3 1 time, huh? Is that good so far? No, it doesn't go into 4, so what do? Just bring it down. Right? It went into the other 2 numbers, though. Right? Now, can we do another layer? Is there something else in common? Yeah, the 2, huh? And you could have done the 2 first and the 3. The order doesn't matter. Do the 2. 2 goes into 4. 2 times 2 goes into 2 1 time. 2 doesn't go into 1, so bring it down. So whenever something doesn't go into something, you just bring it straight down, unchanged. And can we do another layer? Is there something that goes into 2 of these? Well, 1, yeah, but 1 goes into everything, right? We'd be doing 1 forever. We're not going to do 1. Is there anything other than 1? No. So we're done. So what's our answer? Multiply these guys together. Times, 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 times. So 3 times 2 is 6 times 2 is 12. 12 is the LCM. What does that mean? That means all these numbers divide evenly into 12, huh? And they do, don't they? 4 goes into 12, 6 goes into 12, 3 goes into 12. Now, they also go into 24, don't they? Doesn't 4 and 6 and 3 go into 24 evenly? Yeah. And 48, and 96, and 36. All those, there are lots of numbers that they all go into, but this is the least common multiple. It's the lowest of all the numbers they go into. Does that make sense? It's kind of weird that we call it least, but it's bigger than them. But it's least among the common multiples, is what that means. How we doing? Coming up on an hour and a half of me talking at you straight. You still absorbing information? How about, why don't we take a break there? I'll take our 10-minute break, and then we'll come back, and I'll finish this section a little bit and give you the test at 12:30. So take a 10-minute break, come back for a little bit. Okay, shall we try another one? Let's go a few more problems in this section, about 25 more minutes, and we'll take our test. So let's find the LCM for those 3. I want to give this little box thing a try. So put the 4 and the 14 and the 7, put them in an L box for LCM or LCD. So you want to do whatever number goes into at least 2 of them. So what's a number that goes into at least 2 of those? 7 does, and so does 2. You can do them in any order. 2 first, then 7, 7 first, then 2, doesn't matter. But that's right. The answer is already on the screen there, 28, right? So you should get 28 in the end. So I'm going to do 7. So 7 goes into 14 2 times. 7 goes into 7 1 time. 7 doesn't go into 4, so I'll just bring the 4 down. Good so far? You could have started with 2. I started with 7. Doesn't matter. Is that good? Now, is there something else? Now I can do 2. So I do another layer. You just keep doing layers as long as you have 2 numbers that have something in common other than 1, right? We don't count 1. Everything has 1 in common. So do another layer. 4 and 2, what goes into both them is 2. So 2 goes into 4 2 times. 2 goes into 2 1 time. 2 doesn't go into 1, so just bring it down. Right? And there we go. There's no more I can do. I can't do another layer because there's nothing in common anymore other than 1. And so where's my answer? Well, you just multiply these numbers together, huh? Just times, 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 times. 7 times 2 is 14, times 2 is 28, times 1 is still 28, times 1 is still 28. So 28, that's the common denominator for 4, 14, and 7. It's the least common denominator. It's the lowest number they go into. Is that good? Questions I can answer? Okay. So I want to add 1/8 and 7/10. Okay, so the first thing you have to do, so now they want us to do the whole problem, not just find the common denominator, but actually do something with it, huh? So you start, though, by putting the 8 and the 10 in the L box to find the common denominator for 8 and 10. So go ahead and do that. You might know it already. If you just know the common denominator, then you can skip the L box and just go right to it. So what goes into 8 and 10? 2 does. 2 goes into 8 4 times. 2 goes into 10 5 times. What goes into 4 and 5? Nothing. So we're done there. Multiply these numbers together like an L. It's always like an L, right? L for LCD. 2 times 4 is 8, times 5 is 40. So the LCD is 40. By the way, notice that's not the same answer we would have gotten if we'd done 8 times 10. 8 times 10 would have been 80. So again, I'm addressing that concept I see from a lot of students. Say, no, Mr. you just multiply them together. See, that's not true, huh? 8 times 10 is 80. That's not the lowest common. That's a common denominator. That's something they go into, but it's not the lowest number they go into. 40 is the smallest, lowest thing that 8 and 10 go evenly into. 80 is another thing they go into, but the lowest is 40. Okay, so what? Well, now we take that 40. Now we got to actually do something with it. So 40 is going to be the new denominator for both of them. Right? That's why we're finding it, because we want it to be the new common, they both have it, common denominator. Okay, so what, do I just bring down the 1 and the 7 then? Why not? Yeah, because we would change it otherwise, right? We can't change the fraction, right? 1/8 is not the same as 1/40. See, I ate 1/8 of the pie, oh really? I ate 1/40 of the pie. That's a different amount of pie. We can't change the fraction. We can only make it look different, right? Plastic surgery, remove the wrinkles, same person. So how do we do that? We gotta multiply top and bottom of the fraction. Same thing, top and bottom. So we don't change it really. Just change the way it looks. Well, by what? How do you know? Well, you can just take the common denominator and divide by the old denominator. Divide by 8 equals 5. So 5 is what you need to multiply by, right? When you divide, you find what needs to multiply, right? So if I take 40 and divide by the old denominator, I get 5. That's what I multiply that fraction by top and bottom. That makes it 5/40. Does everybody see that? 5/40 is the same as 1/8. If you said, I ate 1/8 of the pie, I ate 5/40 of the pie, that's the same amount of pie, right? If I reduced 5/40 and divided top and bottom by 5, it would go back. 5 divided by 5 would be 1. 40 divided by 5 would be 8. It'd go right back to 1/8, wouldn't it? See how it's just a fancy 1/8? And now the other one, the other divide by 10, right? Again, you divide the common by the old denominator. Right? Can you do the other one? Divide by 10. Can you finish up the other one? That tells you 4. What do you do with that 4? Top and bottom, huh? Is that good? So this would be 28/40. Do you see how 28/40 is just a fancy 7/10? It's the same thing. Do you know what I mean? If I reduced it, if I said, oh, I'm going to divide by 4 and reduce this fraction, 28 divided by 4 would be 7. 40 divided by 4 would be 10. This is a fancy 7/10, huh? I did a little plastic surgery. I made it look different. No more wrinkles. It's the same person still. Okay, now I can add these up. What's that going to be? 33/40. There we go. Common denominator. We did it, which is the answer we had over here all along. Questions on that one? We good? All right. All right. Okay. So LCM again of 15y to the 6th and 75y to the 5th. Okay. So the 15 and the 75, just do the box for them. And then we'll do the y powers afterwards. So take the 15 and the 75 and put them in a box. What goes into 15 and 75? Yeah, 15. Did you say 15? It's a good observation. That's the best way to do it. But I'm going to suppose I didn't notice that and I just did 5. Just because I don't think everybody would notice that right away. But that's a good job if you notice that. I'll just do 5. 5 goes into 15 3 times. 5 times, you divide in your calculator, 5 times 15 is 75. Then you'd have to do another layer. What goes into 3 and 15? 3. Let's do another layer with 3. 3 goes into 3 once, 3 goes into 15 5 times. That's as far as we go. Nothing goes into 1 and 5. Multiply these guys together, right, like a big L. And it is 75, which is one of the two numbers. 75 is itself the number they both go into. Obviously, it goes into itself, and 15 goes into it also. All right, so 75 is the number part of the LCM, but what's the letter part? We have y to the 6th and y to the 5th. What do we do? Well, remember, this is the opposite of GCF. GCF, what do we always do when we have a couple of powers? We take the lowest power, remember? For GCF, we always take the lowest power. And so LCM, we take the highest power. So y to the 6th is higher than 5. So we take the 6. Does everybody see that? So the GCF that we were doing, you take the lowest. These are LCMs. You take the highest. Why? Why do we take the highest? Because that's what they fit into. You realize we're finding a common denominator kind of thing. We're saying, what's a container big enough to hold this or to hold that they would fit in there? That's what a common multiple is. Least common multiple is the smallest container that'll hold either one of them. Well, it's got to have 75 because 15 will fit into that, and 75 obviously fits into 75. Y to the 6th, y to the 5th, you got to take the higher one because they both have to be able to fit in there. Does that make sense? That's what a common multiple is. That's what a least common multiple is. That's the lowest power that they both can fit into. They both can fit into y to the 6th. So you want to remember, and really what I'm trying to do, I'm trying to confuse you right before you take the test. It's a little unfortunate, right? Because you're about to take the test, and you're going to have some GCFs, and GCFs you do the what? Lowest power, right? So if you had these two, you take y to the 5th for factoring. But we go so fast in summer, we're already like a third of the way into the next chapter where we're doing LCMs, and that's just the opposite. You take the higher power. And you know what's funny is the words. It seems like, anyway, the opposite of the words, doesn't it? Greatest common factor, you take the lowest power. And least common multiple, you take the highest power. So if that helps you remember, it seems like the opposite. All right, so 21, c to the 7th, b to the 5th, and 3, c to the 4th, b squared, and 35, c to the 4th, b to the, is that 6 or 8? 6. b to the 6. Okay, 3 of them. So go ahead and do the numbers first off, right? To do the box thing and put the 21, the 3, and the 35 in the box and do the box thing. Use a calculator if you need to. Do the box thing. And then when you're done with that, you do the letters. Remember how you're going to do the letters? You just take the highest power of C, the highest power of B, you're done. So what goes into 2 of those? 3 does, huh? 3 goes into 21 7 times, 3 goes into 3 once. Is that good? But 3 doesn't go evenly into 35, so what do you bring it down, huh? We good? We happy? Now, what goes into 2 of those numbers? 7 does, right? So do another layer. 7 goes into 7 once. 7 goes into 35 5 times. Bring down the 1. We good? Now multiply what's left over. What do we get? 105. Is that good to there? So you should use your calculator. This is a 7 here. So that's 105. And now, what is the LCM? With the letters, you just take the highest power of C. What's the highest power of C? 7th. What's the highest power of B? B to the 6th. And you're done. That's the LCM. That right there is the LCM. That's the smallest container that any of those 3 will fit into. That's what we're finding. Is that okay? Questions on that? All right. Notice for a second. Notice because it's about to get bigger, but it's not harder. If you'll notice the pattern, math is totally patterns. You know, if you get the patterns down, you're good. So what am I talking about? What's the pattern? The pattern is that for the letters anyway, we just take 1, right? I didn't take this C to the 7th and that C to the 4th, add them up and get C to the 11th, and then take some more C's. I don't do that, huh? I just grab one of the 3 C's, don't I? Which one? The highest one. And I just grab one of the 3 B's. Which one? The highest one. And that's our LCM, huh? So see that pattern. They're gonna make it bigger, but it's the same pattern. Which is that pattern again? One of every type, highest one. So it's kind of like going to Target. I'm gonna go to Target after class day. I'll go to Target, and here's my plan. I'm gonna buy 1 of everything, and like I'm gonna buy 1 toaster. Look at all the toasters. I'm gonna buy 1 toaster. I'm gonna buy 1. Look at all the shoes. I'm gonna buy 1 pair of shoes. Look at all the watches. I'm gonna buy 1 watch. Right? And which one? The most expensive one, the highest one. So I'm going to look at all the toasters and buy the most expensive toaster. I'm going to look at all the shoes and buy the most expensive pair of shoes, right? That's what we're doing with the B's and the C's, right? I look at all the C's and take the biggest. Look at all the B's and take the biggest. Good? That's the pattern. So when it gets more complex, remember that's number 11. So 2, x minus 5, and 10. X minus 5. Okay, so those numbers in the front, 2 and 10, you can do the box if you want. Do you just know it? What number do 2 and 10 both go into? 10. Right? 10 itself. But if you're not sure, go ahead and put the 2 and the 10 in the box and say, okay, what goes into 2 and 10? 2. 2 goes into 2 1 time. 2 goes into 10 5 times. Right, with the L box thing. Can I do another layer? Something going to 1 and 5? No, done right there. Multiply these guys together. 2 times 1 is 2 times 5 is 10, sure enough. As we knew. 10 is the container that 2 and 10 both go into. Right? They both go into 20 also, but 10's the lowest container. The lowest number that 2 and 10 both go into. All right, so 10 is the number part of the LCM. What do you do with the x minus 5 thing? Well, that's a letter package. Remember they're glued together? Remember plus and minuses, Costco glue thing? So that's an x minus 5 package. And what do we do for letters? For letters, you take one of each type, highest. So I look at this, this is first power, this is first power, I just take one of them. I don't take them both, huh? Remember, we're shopping at Target, we're just going to buy one pair of shoes. So we just buy one. That's it, we're done. This is the LCM. Does that make sense? One of each type. So if they match, just grab one of them. If one of these was like a third power and the other was a second, I would take the third power, right? I would take the higher power. But they're both just regular first power, so I just grab one of them. It doesn't matter. Is that good on that? All right, I think... Okay, 13. X squared minus 64. X squared plus 15x plus 56. What do you need to do first on these guys? What do they need? Factoring. I'm just going to do that real quick because we don't have time, and I know you can all factor. So I just do this real quick because we got to get going with the examples of how you do LCM. So there they are. I factored them for you. Right? That first one's an FL. Second one's a FOIL. Now, so we're looking at x plus 8 and x minus 8 and x plus 7, x plus 8. And we want the LCM. Can you do that? Go ahead and grab the LCM. We're not even looking up here anymore. These are over. These are gone. Just looking at the stuff we have. How do you do it? Go shopping. Go shopping. Take one of every variety. Every type. One of every type, the highest power. Well, nobody has powers, right? So don't even worry about powers. Just take one of every type. So I go shopping. I come down the first aisle. There's an x plus 8. I'm going to throw one of those in my cart. Come to the next aisle. There's an x minus 8. I'm going to throw one of those in my cart. Come to the next aisle. There's an x plus 7. Throw one of those in my cart. Come to the next aisle. There's an x plus 8. Already got one of those. I'm done. You don't make this squared. Right? We're not adding powers, right? We're not adding. Right? We're just taking the highest one. And everybody's just, all these guys are just first power here, aren't they? So it's just first power. Is that okay? Is that making sense? You're just getting one of every type, the highest power. Now, if there was like a third power here and a second power there, then I would take those higher powers, right? But a lot of the time, everybody's just first power. And so you're just taking one of every type. If there are powers, you're taking one of every type, the highest one. You're always taking one of every type. It's just, is there a highest one? Good? That okay? Always winning. That's the problem. That's the story of my life. I've told you that before, huh? The clock is always beating me. All right, there's that one, and the second one. All right, so I'm going to factor this just to save us time. This one here, what's the first thing you should do to factor that first one? Do what's that? Take out the y, G, C, F. Take out the y. Next step, you should FOIL, do the FOIL thing. So it's going to be y plus 6, huh, to make 36 and 12 in the middle. And what do you do when you have identical twins? You write second power. Right? And that's real important that we show that because remember, because we're using powers in how we come up with the LCM, right? We're taking highest power. So you need to show that power. That's real important now since we're using that idea to help us get the LCM. Okay, good with that one. So I factored that one down as far as it would go. The other one is just a one-stepper, huh? Just take out the y. That's all there is to that one. We good there? So I've got this one factored, got this one factored. Now it's time to find the LCM. Go shopping. So go ahead and let me let you do it. Come up with the LCM. remember the rule, you're going to target one of every type. One pair of shoes, one pair of whatever, one of everything, highest one. So am I going too quick? I'm going to take one y, only one, right? And then a y plus 6 squared. And then I don't need this other y, I've already got one. Just one of every type. And then I need a y minus 12. There it is. Is that good? Just one of every type. One toaster. One pair of shoes. Good. Can I move off that? We got to do one or two more. I'm going to leave you a little high and dry in this section. It's an important section. We'll use this tomorrow. Make sure you work through this tonight. We will be using it. We'll hit the ground running. Tomorrow's going to be ugly, and we'll start with these. If you're still struggling with these, you'll begin to fade starting tomorrow, and I don't want that for you. So do this tonight. Do this tonight. A lot of people say to me, I can't do math, and I always wonder if it's they can't do math or they won't do what math really requires, right? I think they can. I told you I had that gal that, you know, that was really slow with drugs, and she's older like me, and your brain starts to fade when you're older, and she made it, but she worked hours and hours and hours on her homework. So do this section tonight. Really important. Really important. Here's where it'll start to snowball. Like if you don't do this tonight and you come in tomorrow and it's ugly, tomorrow things get ugly. And I'll just start off from the beginning. I'll just go LCD, boom, 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 boom. I'll be assuming you know this. You won't be able to follow anything tomorrow because I'll assume you know this. I have to. I can't reteach it. I don't have time, right? I've got to move forward. Math builds. Like any language, math builds, right? And so that's what starts to happen. So I want to warn you so that won't happen to you. You must keep up. You must keep up. If you don't do this section tonight, if you don't come in tomorrow ready to go on this, you're going to start to fade away because everything we do tomorrow will be lost, and then on we go, and down you go. The buildings fall. That's exactly what happens to people in math. Math builds. At some level, they have a bad week. They don't do it, and it doesn't go away ever because it builds like a language, right? If I did bad in Chinese 2 at the verbs, I don't know, do they do verbs in Chinese? I don't know anything about Chinese. But later on, it would be a problem. I can't say, yeah, we don't do those anymore. No, it's a language. You keep using those, right? So make sure you do this real quick so we can, I just want to show you the new LCM rules. So 6y squared plus 12y and 2y squared plus 14y plus 20. Okay, I'm just going to factor. What's the first step in factoring that thing? And what is the GCF? What's in common? 6 and y. Very good. 6y leaves y plus 2, right? So that'd be 6y squared and 12y. So that one's done. That wasn't too bad. The other one, what's first step in every factoring? LCM. Take out the 2. And then y plus 5, y plus 2, right? Makes 7 in the middle, 10 at the back. It's kind of a messy plus sign there. Okay, yeah, good. Okay. Yeah. So let me help you now with the LCM. So now we want the LCM. We good? So we're looking at these two factored versions. You don't even care about the other stuff now, just the two factored versions. Now, I want you to see that there's different kinds of numbers up there. What I mean is the 6 and the 2 are out front, solo numbers, or on their own. Whereas like y plus 2, that's a package, huh? That 2 is glued. This 2 is glued. This 5 is glued. They're not on their own. They're not solo, right? Whereas this 2 and this 6, they're out front, on their own, not glued, independent numbers. So for them, you do the box thing, right? For the independent out front numbers, you do the box thing. Does that make sense? For all the rest of the stuff, you do the shopping thing, one of every type, highest one, right? See the difference? Out front numbers, the box thing. All the other letters and letter packages, we do the shopping thing. to find the LCD, or LCM. All right, what goes into 2 and 6? 2, goes in 1, goes in 3. Multiply these guys together. 2 times 1 times 3, 6, you probably already knew. 2 and 6 go into 6. Yeah. So 6 is the out front number part of the LCM, right? That handles the 2, and that handles the 6 and the 2, doesn't it? 2 and 6 go into 6. That's the container. They go into 12 also, but 6 is the lowest, smallest container that 2 and 6 fit into, right? The LCM. Okay? Now, what do we do with all the rest of stuff? The solo y, the y plus 2 pack. Well, you buy one of each. I take one solo y. Right? That y is solo. He's not glued to that 6, is he? There's no plus sign or minus. He's independent. Right? I take the y plus 2 package. Come over here. Take the y plus 5 package. Come over here. Y plus 2 already got one of those. There it is. Any order. You could shuffle those around in any order. 6y, y plus 2, y plus 5. Does that make sense how we're doing that? Out front numbers and then the letter and letter packages, one of each type. Well, we probably better take our test, huh? So let's stop there.